estimating the mean and standard deviation from what's called grouped data just requires us to think about what it was that we did when we organized data into like a frequency distribution and then also possibly into a frequency histogram. And then pull off the information to get at least some representative values that then we can estimate the mean and the standard deviation from. Now, I've put up a couple different descriptive statistics ways of people presenting pictures of a data set to us, and then also the formulas for finding the mean and the standard deviation of grouped data. But I'll also talk about what you would do to enter this data just into like a graphing calculator like a TI-83 or 84 and have it do those calculations for us. This way you'll be able to see how to do this with just a scientific calculator if that's all that you have available to use in doing the process, or how to utilize the programs within the graphing calculator if you are able to use those. So here we want to estimate the mean and standard deviation of, this first one is where they've given me a frequency histogram. So I've got my histogram, and remember when we were doing this with a data set, we would take the data set, we determine how many classes we wanted, then we would set up our classes and count how many data values were in each class, and then we put the either class boundaries along the horizontal axis, or if it was marked midway between the start and the end of a bar, that would be our class midpoint if we had that on the horizontal axis. And the height of our bars were the frequency of the times that we saw data values fall in those classes. So when I think about that going back for this, because this one specifically is giving us the numbers along the horizontal axis at the lower class boundary and the upper class boundary for each class, a better representative to use to estimate the mean and the standard deviation would really be the class midpoints. So the first thing I'm going to need to do here is to find the class midpoints of each of these. Again, if those numbers weren't marked and the tick was halfway between the start and the end of a bar and the number would be there, then you would already have the class midpoints and you wouldn't have to do this first step. Now, to find the number that's midway between 25 and 30, I can add those together. So 25 plus 30 is 55, and divide by 2, that gives me 27.5. So midway between that is the value of 27.5. And then the midpoint of the second class that has a lower class boundary of 30 and an upper class boundary of 35. Well, 30 plus 35 is 65. 65 divided by 2 is 32.5. The next class, 35 plus 40 is 75. 75 divided by 2 is 37.5. And then the last class will give me a midpoint of 42.5. So really my X representatives that we're going to use for each class are these midpoints. So I'm going to start and just put kind of a table of values over here. So my XI, the X values that I'm going to use for each class are that 27.5, 32.5, 37.5, and 42.5. And then my frequencies for each class, well, for the first class, the bar has a height of 4. So my first frequency is 4. Then for the second class, my bar has a height of 8. For the third class, my bar has a height of 6. And then for my fourth class, my bar has a height of 2. Now, to find the sample mean, we're going to take each X times its frequency, and then we are going to add those all together and to get our values. So I'm going to take just a minute and multiply each X by its frequency and fill in this column. So now that we this column filled out, just 27.5 times 4 is 110, 32.5 times 8 is 260, etc. And then add those up. That is the adding up of the x sub I times the f sub i's. So that's adding up of each x value times its own frequency, and that gives me the 680. So that's the numerator of your x bar. Now the denominator of your x bar is just the total of the frequencies, the total of the frequency column. So when I take 4 plus 8 plus 6 plus 2, I'm going to get 20. So my x bar is equal to 34. Okay, next up, what does it mean for all of the symbols that we have for our sample standard deviation? Well, here we have to find the sample mean before we do this form of the calculation for the standard deviation. There is a calculation form of the standard deviation that you could also use. Our mean is a whole number value, so it's not going to be hard to use this formula. If this were a decimal, then it just gets really cumbersome to use this formula, and the calculating formula would be actually a better choice for it. But with a mean that is a whole number, it's not so bad. I'm going to kind of shorten up this axis, and we'll make the table for the calculation for our sample standard deviation right over here. So this is what's going to happen. I already know the total of my f sub I is 20 from the previous work. So my denominator I already know is a 20 and then subtract a 1. That's okay. But in the work for the numerator that I have to get, I have to take each individual x, subtract the mean from that x, quantity square it, and then take that value and multiply it by the frequency for that particular class. Now, we only have 4 classes, so we don't have a lot of work that we have to do. The table could get pretty long if you had a lot of classes or when you're doing this for a data set. So we're going to make a table where we have our x's, then where we have our x minus our mean quantity squared, and then multiply that value times our frequency, and then we will then total that whole thing up. So first x is the 27.5. Now when I take 27.5 minus 34 and I square it and then multiply that by 4, so I have the 27.5 minus 34 quantity squared times the 4. So we're just going to write that in, and then we'll just have the calculator go through the rest of the process with it. Next one is our 32.5. So 32.5 is my x. So we're going to take that x of 32.5, subtract the sample mean of 34, quantity square it, and multiply it by the frequency for that particular class, which is 8. Then our next x is 37.5. So we're going to take our 37.5, subtract the mean of 34, square that quantity, and then multiply that by the height of the next bar, which is 6. And then our last one is 42.5. So we have our 42.5 minus 34 quantity squared times the height of that bar, which is 2. So we want to add all of that up. So we're going to do the notation of what it represents, and then we go through and we add all of that up. We get 405. So our sample standard deviation is going to have a numerator here of 405. That's what we just found. The sum of the frequencies, remember, is the total of the frequency column, which was 20. And that 20 subtract 1 gives me a 19 in the denominator. So my S is approximately the square root of 405 divided by 19. And when you do that, you get a sample standard deviation of approximately 4.62. Now, how would you do this if you wanted to use the calculator? Well, in the calculator, we're going to go Stat. And the Stat button is right over by the cursor buttons if you're working with the TI-83 or 84. And then Edit. And in the Edit, you're going to have your lists, L1, L2, etc. So in L1, we're going to put the 27.5, the 32.5, the 37.5, and the 42.5. And then in L2, we're going to put the frequency. So we're going to put 4 across from the 27.5, 8 across from the 32.5, 6 across from the 37.5, and 2 across from the 42.5. Now, the next thing you're going to do is you're going to push the Stat button again. But this time you're going to cursor over to Calculate. And the very top choice after you push the Calculate option or cursor to it is 1 var Stat. Now, if you have an older calculator that doesn't have the prompts, when you push enter on the 1 var Stat, it just shows you a 1 var Stat and it's waiting. And if you need to tell it that you've got this extra information about the frequency in L2, you have to go L1, comma, and your comma's above your 7 on your calculator board. So you're going to go L1, and your L1 is second 1 to get to L1. Comma, second 2 to do L2. So you have to do L1, comma, L2 to get it to look in that second list for the frequency values. Now, if you have a newer calculator and it's got the prompts, it'll say list, and that's where you're going to put the L1. And again, you push your second button and your 1 to get your L1. And then it'll say frequency, and after that you're going to put L2 and then calculate. And then once you calculate, the very top thing you'll see is your X bar is 34, and then go down to the S sub X is what it'll say in your calculator for your sample standard deviation, and you'll see that's approximately 4.62. So that's really the way that if you're allowed to use like your graphing calculator, you would want to do it. You wouldn't want to do it with working all of this out if you have those options in your calculator, because most generally you'll have more questions that you have to do, and it'll just be so time consuming that you'll run out of time to do the other problems. But if you are required to do these out by hand or by just using your scientific calculator, at least you know the way that you can go through the table to get that. Now, let's look at Part B. So Part B is just another way of giving the information. It's got an X list where it's giving you intervals of values. So for the numbers 11 to 15, there were 4 numbers. For the numbers 16 to 20, there were 25 numbers. For the numbers 21 to 25, there were 3 of them. So it's just giving you another way of doing the grouped data. Again, if they're giving me a span of numbers, I have to have a representative for that span. And we use the midpoint for the representative. So 11 plus 15 is 26, and 26 divided by 2 is 13. So I'm actually going to use the number 13 as the representative for that first group. Then my 16 plus 20 is 36. 36 divided by 2 is 18. And then I can see that what's happening with each of them to see that my midpoint of my next one is going to be 23. If you don't see that, again, 21 plus 25 is 46. 46 divided by 2 is 23. So when we go back to the thought process of using our calculator, then we're going to push Stat, and then under Edit, we're going to put the 13, 18, and 23 in our L1. In our L2, we're going to enter the 4, the 25, and the 3. And then we push Stat again. This time calculate. And then our X list is L1. That's where we put the X numbers. And our frequency is L2. And when we go through and work with that, bar, our sample mean is approximately 17.84. And our sample standard deviation is approximately 2.37. And if you needed to, like, run it through the table, the structure from the first problem would be the same thing that you would follow using those numbers. So hopefully that's helped you a little bit determine the estimation of the mean and the standard deviation if you are given data in a grouped setting. Now, one other thing that I need to remind you of, if you are using like a graphing calculator, sometimes stuff from earlier problems stays in when you get to later problems. So if you have another problem after you've done one with grouped data where you told it the frequency list was L2, but you're in a new question and it doesn't have a frequency list, make sure you look across from frequency that it does not reference the L2 when it's not supposed to. So sometimes you have to just remember to update those screens for the current problem that you're working.